All right, guys, we're going to finish up Standard 8 in this one. So I need you to take these notes back out. It's just the notes from last week, okay? I think I have some extra copies just in case you don't have yours. There's a card that's stuck over there by my bookshelf on that tall card, roller card. There are some extra copies on that second part, that second level, if you lost yours, but it's right there, okay? But what we want to do today is make sure we convert a decimal expansion that repeats. In other words, we want to take a decimal that repeats and convert it into a rational number. In other words, we're going to convert it into a fraction, okay? So we've done that. We've done that. And Thursday, I left off, I showed you a video about multiplying decimals by powers of 10. I explained to you powers of 10. Like 10 to the first power is 10. 10 to the second power is just 10 times 10, which is 100. 10 to the third is 10 times 10 times 10, which is 1,000, and so forth. But I told you the exponent corresponds to the number of zeros. So an exponent 2 means that it has 2 zeros. Exponent of 3 means it has 3 zeros. Exponent of 4 means it has 4 zeros, and so forth, okay? All right, now powers of 10 simply push my decimal to the right. The same amount of zeros as the power of 10 has. So I'm just going to recap this. This is recall. I know you already have this in your notes. I do know that. So, except my seventh period, we didn't finish. All right. So, if I'm asking you what power of 10 did I multiply by? And originally it started off between the 1 and the 0, and then it moved between the 2 and the 3. Then I had to bump it 2 spaces to the right, which means I had to multiply by 100. Because if you multiply by 100, which has 2 zeros, it means you move your decimal 2 places to the right. Or you could say this was times 10 to the second. Here it's between the 0 and the 1, and over here it's between the 1 and the 2. So I had to bump it 1, and 10 has 1 0. So that would be times 10. Here it's between the 0 and the 1 on this side. It's between the 4 and the 5. So I had to bump it 1, 2, 3, 4. So 10,000 has 4 zeros. So that means I multiply by 10,000 or times 10 to the fourth power. Here it's between the 0 and the 1. Here's between the 3 and the 4. So I have to bump the decimal 1, 2, 3 places. 1,000 has 3 zeros. 3 zeros. So that's times 10 to the third or just times 1,000. Here it's between the 2 and the 4. On this side it's between the 1 and the 2. So I have to move it 1, 2 places. 100 has 2 zeros. So I'm multiplying by 100, or 10 to the second power. Here's between the 2 and the 4. Here's between the 4 and the 1. So I had to bump it 1 place, which means I'm only multiplying it by 10. Now, I hope everybody understood that on Thursday, because if not, I'm about to have a really hard time explaining this. Okay, so bear with me, guys. Hold on while I turn this air down. All right, we're going to convert repeating decimals to fractions. And again, we're going to use powers of 10 to do it. So you got to really, really pay attention to this part, guys. This part is what you need to learn. Okay, we don't learn this part, we're in trouble, okay? Please, 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 please pay attention. Please pay attention. All right, step 1, you're going to set the decimal equal to x. Because you're going to have a decimal. Because again, we're changing repeating decimals to fractions. You're going to take that repeating decimal and set it equal to x. So suppose you had something like this. That's repeating. You would just set it equal to x. That would be the first thing you would do. And I'm working A down here. I see that that's A, okay? So we're just going to follow the steps. The second thing you would do is you would use a power of 10. So use something up here, one of these. That's a power of 10. Using the power of 10, move the decimal so that the repeating part is in front of the decimal. So I just need one piece of the repeating part. So like right here. Okay, so on this one, only the 3 is repeating. So I need only the 3 to be in front of the decimal. So just one 3, not a whole bunch of them. Let me just get a 3 in front of the decimal. So I'm going to color code this, guys. So right now, with this particular problem, my decimal, if I follow step 2, my decimal is right here. But it says move that decimal so that the repeating part is in front of the decimal. Right now, everything the 3 is repeating, it's all behind the decimal. So I need to move this so that it looks like this. Hold on, guys. Let me erase that. I need to move it so that it looks like this, guys. Okay? So the question becomes, what am I multiplying by to move my decimal from here to basically here, guys? Because now I got the repeating part in front of the decimal. So it says put the repeating part where? In front of the decimal. Well, I got the repeating part in front of the decimal. So I'm moving my decimal from here to here. So what am I multiplying by? Well, I hope everybody knows you're multiplying by 10 to move that 3. 1 3 in front of the decimal. So please, please, please pay attention. Okay, this is the second thing. So I'm going to rewrite this so it looks like this. Okay? So now the repeating part has gone from here. The decimal has gone from here to here. Basically, you just slid it over 1, okay? Which means that you had to multiply by 10. Which means you need to multiply this side by 10 as well. I'm going to use a little dot for times. So if I multiply this side by 10, it moves the decimal from here to here, which gives me this. But if I multiply this side by 10, it gives me 10x. Okay? So that's one equation. You're actually going to set up 2 equations. But notice that the first one was just, what do you multiply the decimal by, the number by to slide the decimal with the repeating part in front of the decimal. And then the third step says, using a power of 10, move the decimal so that only the repeating part is behind the decimal. And this is going to make a second equation. Okay, so let's look at what we do have. And you always go back to number 1, your original. This is what I do have. So I need to move it so that only the repeating part is behind the decimal. Well, if I look, all 3's, the only thing that's repeating is the 3. But only the 3's are behind the decimal. So for the third thing, I just keep the same equation I set up on step 1. So there's no need for me to multiply by a power of 10. If there's no need for you to multiply by a power of 10, you keep your original equation that you set up. Basically, you keep what you set equal to x. You keep it, bring it back down. So number 1 comes down to number 3. Only if you don't have to multiply by a power of 10. And I don't. And I keep the x. I'm allowed to put an imaginary 1 in front of the x, okay? So again, what I'm doing is I just kept the original equation. So the first thing I did, guys, I set it equal to x. That's, if this will stay, that's this right there. That becomes number 3, simply because I'm not multiplying by a power of 10, because all of my digits of 3 are already behind the decimal. So they're already all behind the decimal, and it's only that's behind the decimal there. So I just take that and put it right here. Equation 1 is the same as, or equation 3 is the same as equation 1. Okay? Okay, now it says stack them at that point. So I'm going to stack them. They're already stacked. Okay. Then it says subtract them. So I'm going to subtract here, subtract there. And then it says solve and simplify. So watch. So 3 minus 3, 0. 3 minus 3, 0. 3 minus 3, 0. Bring around my decimal. 3 minus 0, 3. I don't need those zeros, guys. So I'm just going to drop them. So that's 3. And then bring down your equal. And not 10x minus 1x is 9x. Okay, now guys, this is what we call a one-step equation. We're going to write this a little better. This is a one-step equation. To get x by itself, all you do is divide both sides by 9. So 3/9 is equal to x. And you could simplify this thing. You could divide them both by 3. So I know that x is 1/3. In other words, this x is 1/3. But this x is equal to 0.3333333, blah, 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 blah. So 1/3 is equal to 0.3333333, blah, 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 blah. Okay? So 1/3 is equal to that repeating decimal because 1/3 is my x. Okay, some of you probably did not understand that, which is why I'm going to do it again. If you understood it, great. If you didn't, well, watch me again because I'm going to do it again, guys. And I'm going to follow these same instructions. I'm going to follow the instructions at the top, okay? So the very first thing I'm going to do is set this equal to x. Oops. Okay, that makes an equation. Okay, so I do that first. And second, I make sure I get a repeating part. And the only thing that's repeating is a 3. 3 is repeating. So I just need to get a 3 in front of the decimal. So I need to get it to look like this. Okay? To get it to look like that, all I have to do is slide this decimal one place to the right. But if I slide it to the one place to the right, that means I'm multiplying by 10. Which means I need to multiply on this side by 10. Because if you want to keep an equation as an equation or keep it balanced, what you do to one side, you must also do to the other side. So if I multiply this side by 10, it gives me this. If I multiply this side by 10, it gives me 10x. I don't say x10, I say 10x. I put the 10 first. Okay, that's step 2. Then I move on to step 3. Move the decimal so that only the repeating parts now behind the decimal. Well, if you look at the original equation, and you always go back and look at the original, now you may want to put that little note. Always look back at the original equation. Which is going to be your step 1. To decide if it's only the repeating part behind it already, or do you need to move something. So if I go back in step 1, I only got 3, 3, 3. I only got 3s. I only got the repeating part behind it. So if that's the case, your equation 1 and equation 3 match. You just make your equation. This one is saying the equation in step 3 is the same. And I know this has a 4-3, but I can put and so on. It still has a 4-3 there. And put your x over here. So you wrote that whole thing down and put it right there, okay? Now I'm allowed to put a 1 in front of it, a variable that doesn't have a number. It's called a coefficient of 1. Then after you do that, you make sure they're stacked. They are stacked. They're stacked on each. They're lined up, basically. And then you subtract them. Subtract, subtract. So on this side, 3 minus 3 is 0. 3 minus 3 is 0. 3 minus 3 is 0. 3 minus 0 is 3. So this basically changes to the number 3. And on this side, 10x is minus 1x is 9x. And then you solve because you got an equation. Divide both sides by 9. Then match together. That's multiplication. Opposite of multiplication is division. So I get 3/9 equals x. And then it says simplify. Divide them both by 3. So 3/10 repeating just equals 1/3 as a fraction, guys. Okay, let's try something like B. Okay, trying something like B. Set it equal to X. Here we go. Set that equal to X, and that's step 1. Step 2 is to figure out what's repeating. Well, 6 is repeating. So I need to get a 6 in front of the decimal. So I need to move it right there. And then I get a 6 in the front of the decimal. So I just needed to get it to look like this. So whatever is repeating on step 2, you just need to get that repeating part in front of the decimal. So I just need to get a 6 in front of the decimal so it looks like this. Okay? Now I got a 1 6 in front of the decimal. I'm good. Okay, that's what I need set up. But that means I will have to multiply by, I'm going to use a little dot for multiplication. I have to multiply by 1,000, which means on this side, I must also multiply by 1,000. What you do on one side, you do to the other. So to get from step 1 to step 2, I will have to multiply the decimal in step 1 by 1,000, which means I need to multiply x by 1,000 on this side, which gives me 1,000x. That's step 2. Okay, now we got step 3. Let me erase this. All right, now, step 3 says, here we go. Using the power of 10, move the decimal so that only the repeating part is now behind the decimal. So 6 is repeating. 6 is the repeating part. But I needed to get it where it's just all 6's behind the decimal. So I want the decimal right here so that now all 6's are behind the decimal. That's in step 3. So I need it to look like this. And you're going to line your decimals up, guys. 41 point, you know that means you're moving it to 666, blah, 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 blah. All right, so what am I multiplying by? So let me erase this. I've already used that. I've used 1,000 to get from step 1 to step 2. But to get from step 1 to step 3, what am I multiplying by? To get from step 1 to step 3. So I need to slide it 2 places over. So I'll be multiplying by 100. So I'll multiply that by 100. Multiplying by 100 puts me at that 41 point, and then all the 6's are now behind the decimal. And only all the 6's. Beforehand, I had a 4 and a 1 behind the decimal. So I just got rid of those two numbers by multiplying by 100 and having all 6's in the back. Remember, on step 3, you can only have the repeating part in the back. So since the repeating part is 6's, I can only have the 6's in the back. So that's 41.66666. But again, that means I'm multiplying by 100. So over here, multiply x by 100. It's 100 x's. And after you get that set up, I need you to subtract them. Subtract, subtract. On this side, these 6's cancel. 6 minus 1 is 5. I'm going to have to regroup here. 7. It's 375. And then over here, 1,000 x's minus 100 x's is 900 x's. And to solve for x, I just divide both sides by 900. These cancel. So I end up with 375 over 900 equals to x. And I'm going to go back to quarters because I showed you all this other day. To simplify, just think about quarters. So how many quarters make $3.75? 4 quarters make $1. 8 quarters make $2. 12 quarters make $3. And 15 quarters would make $3.75. Now I just need to think about how many quarters make $9. Well, 4 quarters make $1. I would just need to have those 4 a total of 9 times. And I'm not going to keep writing this out, guys. So we'll have to have 4, not 1, 2, 3, 4, but 9 times, guys. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, total of 9. So if I got 4 9 times, That means I have 36. Okay? And for some people, I probably should have kept. Let me go back and just keep writing it out. Because some of y'all are not going to understand unless I write it all the way out. Another 4 quarters make 5. Another 4 quarters make 6. Another 4 quarters make 7. Another 4 quarters make 8. And another 4 quarters make 9. That's 1, 2, 3, 4, 5, 6, 7, 8, 9 groups of 4, which is 36. And I can divide both of these by 3, guys. That would give me 5 over 12. So this equals to 5/12 in simplest form. So I know that 0.4166666 blah, 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 blah is equal to 5/12 in simplest form as a fraction. Okay, let's try and see. See? Okay, you pause the video and tell me the first step. Good. The first step is to set it equal to x. The second step. The second step is to decide what's repeating and get it in front of the decimal. Well, I know 4 and 5 are repeating. So I'm going to have to get a 4 and a 5 in front of the decimal. And the rest of this can just stay. But to do that, I need to multiply by 100. That's going to push it 1, 2 places over. So which means I multiply this by 100. So to get from equation 1, or step 1 to step 2, I'll just need to multiply both sides by 100. Multiply this by 100, it gives me this. Multiply this by 100, it gives me that. Okay, there we go. Okay, now I'm going to erase that. Let's figure out what I was multiplying by to get from step 1 to step 2. To get from step 1 to step 3 now is different. To get from step 1 to step 3, it says, using the power of 10, move the decimal so that only the repeating part is behind the decimal. Okay? So let's see. Go from step 1 to step 3. Well, look, what's repeating? 4, 5, 4, 5, 4, 5. Well, that's already only the repeating part. So if it already is what I need, then step 3 is the same as step 1. I don't have to multiply by power of 10. But make sure you keep your decimals lined up. And that's going to be equal to x. Put an imaginary 1. Now I can subtract. Here, cancel, cancel. That makes 0. And 45 minus 0 is 45. And then 100x minus 1x is 99x. Now just divide both sides by 99 to solve. So you get 45 over 99 equals to x. I'm going to divide both by 5. I'm going to divide both by 9 because 5 won't go into 99, folks. I'm sorry about that. 45 divided by 9 is 5, and 99 divided by 9 is 11. So basically, this repeating is 5/11. Excuse me. That's all you do. I'm going to fix this because I don't think you all are ready for a whole number. Okay. So let's try this one again. You can pause the video and try this one on your own if you want to. Probably would be good for you to get some practice. But go back and look at your directions and see if you can follow step 1, step 2, and step 3. Excuse me. All right, step 1 should have been set this thing equal to x. Step 2 should have been to get the repeating part, only the repeating part in front of the decimal. Just one of them. Not a whole bunch of them, just one of them. So what digit is repeating? That was 3. 3 is repeating. My job is just to get a 3 in front of the decimal. That's all my job is on step 2. So I just put the decimal right there, and then I have a 3 in front. 83.333, blah, blah, blah. Okay? So to get the decimal from here to here, I got to scoot 2 places. That means I'm multiplying by 100. which means I need to multiply x by 100. So multiplying by 100 on the left side gives me this, and multiplying by 100 on the right side gives me 100x. Okay, that takes care of step 2. Got that? Let me erase that. Okay. Then I need to go from, I've done step 1 to step 2. Now I need to do step 1 to step 3. Okay. Now I need only the repeating part in the back. So it says using the power of 10, move the decimal so that only the repeating part is behind the decimal. So I just need the threes, just the threes behind the decimal. So go back to step 1. If I move the decimal here, I get just the threes behind the decimal. So I only need to scoot it one place over. That means I'm multiplying by 10. If I scoot it one place over and line my decimals up, make sure you line these decimals up so you can subtract. So they'll be stacked correctly, guys. Okay. So that 8 is 8, and then it's a whole bunch of threes behind it. So right, if you only write 3 of those threes, as long as you write ellipses. I know I have 4 up here, but who cares? Those ellipses just means the threes keep going, okay? All right, multiply this by 10. That's going to give me 10x. Subtract. They cancel. And 83 minus 8, well, I can't do 3 minus 8, so that becomes a 7. That becomes 13. So that's 5 and 7. And then 100x's minus 10x's is 90x's. Divide both sides by 90. That's going to be 75 90ths equals to x. I'm going to divide both by 5. That's going to be 15 over 18. I can divide both of these by 3. That's going to be 5 over 6. Now, if you forget that, guys, you can use the ladder. Like I know 5 will go into both of these. 5 will go into 75 15 times, and 5 will go into 90 18 times. And I do know 3 will go into both of these. 3 will go into 5 times, and 3 will go into 18 6 times. And the only thing that go into both of those is a 1. So basically, when you get to a 1, you just look at these numbers. That's your simplest form. That's 5 over 6. And you don't even have to write that 1. You can say the only thing that will go into 5 and 6 is 1. So 5 6 must be my simplest form, my fraction in simplest form. All right, now I'm going to show you something, guys. So I'm going to go back and show you this. Suppose I would have left that at 7. Doesn't matter. 7 will act as a whole number. Whole numbers always sit in front of a fraction. So you could have just written, hold on, guys, let me erase this up here so I can have some more room. You could have kept the whole number 7. And then whatever you got for the fractional piece, just put 7 and 5, 6. But you would have still had to set this equal to x. Not the one with the 7 in it, okay? You'd have to set this equal to x, set this one equal to x, and solve all the steps and get down to 5, 6. And then that 5, 6 sits next to the whole number 7. So basically, you're still ignore the 7. The 7 changes to a 0. You set it equal to x. You get your 5, 6. But if you know in actuality you have a 7 as a whole number, you make sure you put it back in front of the 5, 6, okay? All right, let me see if I can show you some shortcuts. Okay, so using the calculator, and I'm not in class, so we're not using the calculator. I'm going to do it for you. It says write each of the following as decimals. And we're going to determine if a shortened method can be used for certain repeating decimals. Okay, so I'm going to take 1 and divide it by 9. You punch it in from top to bottom, and this is what I get. 2 divided by 9, and this is what I get. 7 divided by 9, and this is what I get, guys. Some of you probably already see a pattern. Okay. Some of you should see something about these ninths. I don't know. One's a one, two's a two, seven's a seven. Oh my goodness. Okay, it's my dang on numerator. All right, hold on. Let's see. Let's keep going. Let's do 24 divided by 99. This is what I get. Now I get 2, 4, 2, 4, 2, 4, 2, 4. It's my numerator again. Okay, 8 divided by 99. 0, 8. 0, 8. It's my numerator, but with a 0. Okay? In front of it. To still represent 8. 57 divided by 99. This is what I get. It's this numerator again. Okay? Let's try this. 125 divided by 999. Watch this. I get my numerator repeating again. Okay? 973 divided by 999. Watch this. This is what you get. It's this numerator again. So 27 divided by 999. Watch this, guys. This is what you get. It's this numerator again, but with a 0. Okay? So I hope you're able to tell something. Like if you got nines on the bottom, whether it's a sequence. When I say nines, I mean a sequence of nines where you got 999, 999, 9,999. Those are a sequence of nines. Excuse me. Okay, those are a sequence of nines, guys. So if you have a sequence of nines in your denominator, your numerator is going to repeat, but it's going to repeat the same number of digits like as your denominator. Well, your denominator, if your denominator is 9, it's going to repeat one digit. If your denominator, and it's going to repeat one digit of that numerator. If your denominator is 99, it's going to repeat in 2 digits. That's why, like, this one was 99, but you just can't put 88888 because there's only one digit repeating. So you got to do 0, 8. It still got to be the numerator. Okay? 2 digits, 0, 8, because 99 is made up of 2 digits. If your denominator is 999, it's going to repeat in digits of 3. Okay? Just like this one. Not 125, 125. That's 3 digits, 3 digits, 125. But when you get something like 27, 27 is 2 digits. So we got to add a 0 in front to make sure it ends up being 3 digits, 1, 2, 3. Same amount of digits in that sequence of nines. Okay, so let's just take a look at this. Please focus on the decimal form for each fraction, which I have highlighted in yellow. You should notice that the decimal form has the same amount of recurring digits as the nines in the denominator. So, like, how many nines are in this denominator? Only one. One. So you're going to have one digit recurring. Okay, and that digit just happens to be your numerator. Here, how many nines do you have in your denominator? 2. So you're going to have 2 digits recurring. And those 2 digits just happen to be your numerator. How many nines do you have in your denominator? 2. Well, you got to have 2 digits recurring, so you got to at least put an 8 because it's got to be the digits in your numerator. And you can't change 8 to a different number. You can't put a 1 there. You can't put 18, 18, 18. You can put 0, 8, so now it's recurring in 2 digits. Same thing here. How many nines in your denominator? 3. So your numerator is recurring in 3 digits. How many nines in your denominator? Right here. 3. So your numerator is recurring in 3 digits. That's why you got to put a 0, because a 27 only has 2 digits. Now I can say 027, 027, that's 3 digits. Okay, let me go back to this. It says, you should notice that the decimal form has the same amount of recurring digits as the 9s in your denominator, and those digits correspond to the value of the numerator. Okay, so let's see if we can do it without, I'm going to do B first without doing the long method on some of these, okay? Use the shortcut to write the fraction form of each of the following repeating digits. Okay, so that's 3 digits recurring, 154. Excuse me, 145, 145, 145. So since it's 3 digit recurring, I know it has a sequence of 3 nines on the bottom. And it's recurring, a 1, 4, and a 5. That's it. I can simplify it if I want to. I don't feel like it right now. Here it's 0, 4, 0, 4, 0, 4. That's 2 digits recurring, so it's 2 nines in the denominator. But you don't put 0, 4, guys. Just put 4 in the numerator. Okay, these are a little different. I'm going to go back to A. So the one with bar notation just means it's a bunch of 5s repeating. Just write it out like that. Well, only the 5 is repeating. 5, 5, 5, 5. That's 1 digit repeating. And it's that digit 5. That's it. Here, I'm going to write this out. This is what's repeating. Here it's 2 digits repeating. 87, 87, 87. So we're going to use the sequence of 2 nines, 99. And those 2 digits of repeating are 8 and 7. So that's what that equals. That's all you do. All right. That's it, guys. I'm going to upload some practice. I want to see if you can do this. I'll probably do more of this tomorrow, okay? All right, but I'm going to upload practice to see if you can do it. You try working on it. If you have to, work on it with a peer. Do not get loud. Coach Thomas will be watching you and other teachers. Please don't let them tell me that you were loud, okay? Just actually work. If you have to go back and rewatch the video, work on your practice for me. Particularly if you know you're going to have problems with this, start on this first and work your way backwards to the easy things that you already know that you can do on your own, okay? Thank you.